Hi, in this video we're going to go over a really simple strategy vault just to illustrate how strategy vaults work, and we'll use this as a basis for understanding kind of basic vault mechanics, and then we'll take a look at some more complicated vaults. But the general idea of a strategy vault is it needs to implement this particular interface, iStrategy vault. Decimals will always return 8. So notional strategy vaults, the strategy tokens are denominated 8 decimal precision, much like everything else within notional. So that's just how that is hard coded. Name and strategy are both fields that will largely be hard coded and used for the user interface primarily. The strategy idea is a way for us to group similar strategies that require the same kind of UI code, even though the different strategies may be implemented in very different currencies. So the cross-currency fCash vault that we'll look at is an example that can be implemented in many different currency pairs, in many different currency pairs. Now, the vault controller on the notional side is going to call these four methods. Deposit from notional is going to be called when accounts enter a position and when they roll their positions. So that'll be called on the vault. Redeem from notional is going to be called when accounts exit their positions and during settlement. So we'll take a look at that as well. Convert strategy to underline is used by notional to determine the valuation of a certain balance of strategy tokens. So notional is going to call this method and expect the evaluation in the primary borrow currency to be returned. And this is how we will ensure that the account maintains a minimum collateralization ratio. And the repay secondary borrow callback is only used on vaults that are borrowing in secondary currencies. We don't have an example of this, but if it's not being used, it can revert and it won't be called anyway. When vaults are borrowing in secondary currencies, they're required to repay their secondary borrow debts as positions are exited, and in order to reduce any sort of ambiguity or like any off by one distinctions, this notional is going to call the repay secondary borrow callback and ask for a specific amount of underlying in that particular token. So what we've built is what we call the base strategy vault, which is sort of like a starting point, implements a lot of the base expected behaviors of strategy vaults. And from this implementation, developers can build on top of it and build more specific strategies. So we have a number of mutables and some storage here. This particular implementation is intended to be upgradable via the UPS pattern. So that's what we have here. Notional does send and receive ETH. This is here. However, if you're using a proxy contract, you need to make sure that this is enabled on the proxy as well. These are just a number of getters and initialization functions, so nothing terribly interesting. We'll talk about executing DEX trades and how we do that in this video as well. And these are the abstract methods to be overridden. So deposit and redeem are internal here. Implementation, we've implemented the basic authentication checks around deposit for notional and redeem for notional for the developer. We've also put in this a little bit of logic here to handle redemptions. So on redemption, the vault is first going to sell the expected number, the requested number of strategy tokens here for the primary borrowed currency. So, and this is how much the vault has in hand right now at this point. This logic will determine how much is going to get transferred to notional and how much is going to go to the receiver. So in the normal case, when an account is exiting their position, they will receive what's required to repay their debt will go back to notional, and anything in excess will go to the receiver here. The receiver specified here. If there's a shortfall in what's raised, we're going to transfer everything to notional, and when we do that, notional will then try to recoup the shortfall from the account's wallet. If it can't do that, it will revert. The other special condition here is if the account is specified as the vault itself. In that case, what we will be doing is settlement. So during settlement, all of the cash redeemed will go back to notional and be held as repayment for the vault's debts. So that's just a special condition there. And with that, we'll take a look at the cross-currency fCash vault. So the cross-currency fCash vault, this particular strategy involves borrowing on one currency in notional and lending on another. And for this vault, it's only going to be deployed in situations where the two currencies are pegged in value to each other. So DAI and USDC, if we list frax, it would be like, USDC and frax or something like that. So in the past, we've seen that interest rates for stablecoin pairs can diverge pretty significantly on notional. We've seen 4 or 5 percentage point differences in lending and borrowing rates on the same maturity. And so the idea behind this vault is it allows accounts to arbitrage those rates into line with a lot of capital efficiency. So we'll allow people to take 10 to 20x leverage when they use this vault. So taking a look at it, we have a set of deposit params and redemption params. These are going to be used to specify how the account is going to trade in and out of the currency mainly. We have our initializer here, which specifies the lend currency ID and the borrow currency ID. So again, this could be USDC or DAI. We'll just continue on here. We'll skip settlement for now, and we'll take a look at convert strategy to underlie. So in order to get the valuation of a certain number of strategy tokens, in this case, the strategy tokens will be the fDAI. It will be the lending position. So fDAI in our example. And the valuation there post maturity is going to be the notional value of the fDAI because it has matured, and that's what the account now has. Prior to maturity, we use this get present fCash value, which is available on notional to get the present value of fCash. So this present value function uses notional's internal interest rate oracle to get that price or to get that valuation. So this is flash loan or flash loan resistance. From the trading module, what we'll do is we'll get the oracle price between DAI and USDC. We use Chainlink to get that oracle price, and generally this is going to be quite close to 1, but in the chance that there is some sort of depeg between the two tokens, we'll be able to liquidate able to liquidate here. So that is that. And what this is going to return in our example, since we are lending DAI, this is going to return USDC in 6 decimal precision, the value of the position in 6 decimal precision in USDC terms. So now we'll look at deposit from notional. So this method is going to be called by notional when funds are being deposited and the strategy token balance should increase. So what we'll do is we'll create a trade struct here. What we're doing is we're selling the underlying token, we're selling the borrowed currency that we're depositing, and we're purchasing the currency that we want to lend. So selling USDC, buying DAI. The user can specify slippage limits here and also specify any exchange data that they need. So this will be things like the Uniswap V3 path. If we're using 0x, it'll be the 0x bytecode. From here, we'll call execute trade. So execute trade is going to execute an exchange through our trading module, which will ensure that different limits and other sort of guidelines are met to make sure we make a safe trade through the DEX. And the last step here is going to be to lend the DAI that we received. So we received this much DAI. We're going to calculate how much fCash we would receive for that. And then we're going to go ahead and lend that position on Notion. And then we return the fCash, the fDAI that we've lent as the number of strategy tokens now held by this account. So this is going to go, once this value is returned to the notional side, it's going to mark the number of strategy tokens this account now holds and sort of check the collateral and then complete that transaction. On redemption, we have 2 options for redemption. So we'll take a look at redeeming prior to maturity first. So redeeming prior to maturity on notional entails selling the fCash back to the AMM. So this is also considered borrowing. Now the account is not going to go into debt here. It's going to reduce its lending balance. So what we do here is we'll encode that trade, given the number of in our example fDAI that we want to sell. So now we'll have some amount of DAI that we've raised, and then we will execute another trade to sell the DAI in exchange for USDC. And once we execute that trade, this returns how many tokens we've purchased, and then that will go back into the base strategy vault, and the profits will be divvied up accordingly. Now, in general, for this particular strategy, accounts will likely want to hold their position through to maturity, and that's how they'll be sort of guaranteed the fixed return that they got when they entered into the vault. So, so this is this path, once we're past maturity, can only take place by the vault calling redeem from notional, and we'll take a look at how that looks in a bit. But when the account does call this method, it's going to call settle account. This is a notional method, not a vault specific method. This is basically to update the bookkeeping inside regular notional for the fCash to be converted into a cash balance, which we withdraw in full and redeem it to underlying. So that gets us the full balance of DAI that we're owed at maturity for this vault. And then from there, we'll proceed to trade it back to USDC. So to take a look at settlement a little bit more, so that method that we just saw post maturity redemption will be initiated via a call to this method, settle vault. So settle vault is there's no authentication on this. Generally, with settlement, similar to liquidation, we strive to make settlement as trustless as possible, so anyone can call these methods. Now, settle vault, there's no incentive for calling it. So generally, this is just going to be something that probably like a keeper bot or Notional Incorporated kind of like bot does, and and any gas cost might be reimbursed over time. So what we'll do here is we will so what we allow is the caller to specify the number of strategy tokens they want to settle per call. So this is mainly just as a safeguard in the case that trading out of a large balance of DAI back into USDC somehow incurs a lot of slippage, and that trade might have to be broken up across a few different transactions. For this particular case, that shouldn't be a problem, since the maker has a PSM which can handle like quite a significant amount of trading before we do see slippage. And furthermore, this need to trade positions out at settlement is definitely a risk when it comes to leverage vaults. And so one way that we will guard against this is with the maximum vault capacity. So we know that upon settlement, we're always going to have to sell less than the maximum vault capacity. So so it does limit like the overall like exposure we have to slippage. But in this particular example, so generally speaking, the value passed in here is likely going to be the total strategy tokens because we can sell it all in one go. And so we will do that. We will get the value, since we're post maturity here. We're going to convert the tokens to their underlying value, and then we are going to calculate the minimum purchase amount that we're allowed to have, and that's based on some slippage limit that's preset in the vault. From there, what we're going to do is call redeem strategy tokens to cash, and this method is on the vault action. So this is on this method is on the notional vault controller itself. It can only be called by the vault itself, and what it's going to do is call the vault back. This is going to call redeem from notional with these parameters, so it's going to do a little callback here, and it'll update the accounting in the vault state to put asset cache and increase the asset cache and decrease the strategy tokens here. So so what this is in effect going to do is going to go to the vault action method here. When we go into redeem without debt repayment, that's going to come back through to this redeem from notional method, hit this if block, we'll withdraw all our funds straight to USDC, and when we exit this settlement here, we should have updated our vault states with the total number of strategy tokens remaining. If the total number of strategy tokens is 0, in this case, likely what we'll have done is like sold all the strategy tokens back to USDC. We'll call this settle vaults method. So the settle vault method is also on the vault controller, and what this does is finalize any bookkeeping for the vault for that particular maturity on the vault, and stores a number of values to make sure that that when accounts come to exit their positions post maturity, they get the proper amount of profit for their position. So that's kind of the life cycle of leveraged vaults. And this one was, I think, relatively simple. But in the next video, we'll take a look at the balancer strategy, which has a little bit more complexity to it.